Good morning and welcome to the opening session of the Transition Faster Let's Talk Wind conference. I'm here today with some global leaders from the wind industry and the energy industry. My name is Caroline Kamerbeek and I'm the moderator of the session. In daily life, I'm the Vice President of Marketing and Communication at DNVGL's Energy Business. I'm joined today with four distinguished guests. Let me start with Remy Eriksson, Group President and CEO at DNVGL. Welcome, Remy. Andrew Garrad, wind pioneer in the wind industry for more than 40 years and founder of Garrad, which is now part of DNVGL's business. Sheri Hickok. Welcome, Sheri, CEO, GE, Renewable Energy, Onshore Wind in Asia. Welcome, Sheri. And then Elbia Ganoum, CEO of ABE Eolica, the Brazilian Wind Association, and also Vice Chair on the GWEC board. Welcome to you all, and thank you for being here today. Before we continue, I have a question to the audience. You can put in your questions that you have during the session on the left of your screen, and the questions will be answered at the end of the session. This session will be recorded, so it can be also listened to then or watched after this session. Thank you very much. So let's get started with Remy. First question for you. Looking at the leaders in industry and in society, what can they do to transition faster to a clean energy future?
I believe what leaders should do is that's a broad question first, and I cannot answer for all leaders, except to say that we all share a common responsibility to act urgently. Also, we as leaders must not underestimate the scale of the challenge that we have in front of us. And let me give you one example on that. That is in our energy transition outlook that we released in September last year. We estimate that the pandemic has reduced carbon emissions by roughly 8% during 2020. And to reach the goals of the Paris Agreement, we have to achieve the same amount of emission reductions every year the next 30 years. And that we must do without the enormous costs to lives and livelihood that we have seen in 2020. Also, I would like to say that if we accept that many countries will be above zero carbon by 2050, for example, China they have now declared zero by 2060, then we must ask who is going to be below zero. So far, I can think of very few countries, Sweden is one, who are targeting carbon neutrality before 2050. Industries like aviation and maritime are already struggling with targets to not eliminate half the emissions by 2050. So I ask again, who is going to be below zero? And my point here is that commitment then has to come from the private sectors and companies. So that I think is something we leaders has to be strong ambassadors for and lead from the front.
Yes, thank you very much, Remy. Sheri, I remember you've worked in the automotive industry before joining the wind industry for a long time. Are there any learnings from that industry that you think we can use in the wind sector?
Yeah, thank you, Caroline. I think it's a great question, and probably something that we look past too often, but that is to look at our past and try to learn from that proactively. So for example, the automotive industry, has gone through cycles of really trying to optimize and improve the throughput, the cost, the access to transportation. And as a part of an OEM in the wind industry, one of the things we're really working through is how do we take those learnings on what the automotive industry has already done through platforming, through supply partnerships, really reaching out, partnering more at the regulatory level with countries to try to advance wind supply faster at a lower LCOE to help speed up the energy transition. I think we can learn from the industries of the past to see what they've done and to try to apply those versus trying to relearn everything ourselves within the wind industry.
Yeah, I think that is a very, very good point. And thank you, Sheri. And what I see is we are currently still in the global pandemic, unfortunately, all of us. And Andrew, you had some interesting insights in almost how the global pandemic, although it's very negative, of course, also has some positive sides with regards to the role of experts that we currently have. Can you elaborate a bit on that and how that can help us transition faster?
Yes, well, I've been thinking about how we've reacted to the pandemic, and we've seen the pandemic, or clearly recognized it globally as a global issue. And before the pandemic came along, everybody was putting climate change as the number one issue, and COVID seems to have displaced that a little bit. But of course, the climate change is still sitting right there, ready for action. If you look at what governments and other organizations have done in reaction to COVID, you see some very difficult and firm measures taken. And people have accepted that. So people have accepted that because they accept the pandemic is there and we need to do something about it. The problem we've always had with climate change is people perhaps knowing it's there in an intellectual sense, but not recognizing the severity of the issue. If we think of climate change as another COVID, then I think we can see that really quite dramatic actions could be taken and people would support them. And as I get older, I think I get a bit more dictatorial and less democratic. And if we really agree, that the climate change is the most pressing issue for our globe, then we should act on it exactly as we have with COVID, which means not discussing what we might do, but actually doing it and saying, if you look at what happened in Europe, that the reason why we have so much renewables in Europe now is because there was the EU directive to have 20% by 2020. If not, we would be punished. And we did it. Mm-hmm. And so we have to take the same attitude, I think, to renewables, climate change, as we are now with COVID. It may be unpopular in some places, but we actually need to get on and get some action.
Yeah, thank you. That's a very good insight, and also the rise of the credibility of experts has risen in the past years. I think that's also very positive, yes. Of course. Now, if you move to the kind of next topic, which is very related, this is also the cross collaboration. How it's not just the wind industry that, of course, can make this big step forward. So I was wondering, Albia, if you look at Brazil, where you do not have big packages and subsidies, you've chosen a different approach to go faster and pull in also investors from abroad. Could you elaborate on that and how that helps your country go faster? Because it might be an example also for other fast developing regions in the world.
Yes, thank you. We noticed that collaboration between industry, society works well. We learned this in pandemic crisis. I'm not talking about the energy transition in developing country as Brazil. Brazil is a very rich country in sources for renewable. And we have a good alternative to attract investment. The point in Brazil is that we don't have money to prepare a big package like other countries. And what is important for us? We need to understand that it's very important to arrange the environment for investments and to attract investment from abroad. In the last year, we have been improved investments in renewables like wind, solar, and the wind offshore. Then what we need to work now that we have been discussing, we need to understand that this investment in energy transformation needed to be a way to recover the economy. As other countries has been discussing about the green recovery, Brazil needs to understand better this process, and we need to prepare our market and attract investors and look for this industry for energy transitions with a new way and to attract these investments. I believe that we are going in very good way, but we need to improve some things made in special when you're talking about to attract more investors and to arrange more our environment to maintain and to improve your doing business here.
Yeah, I think that is really interesting to see that you have this resourceful country and that you find alternative ways to invest in and to, let's say, increase the pace of the energy transition, which is very interesting. Remy, diving into the topic of collaboration, cross collaboration, DNVGL has a long history of bringing industries together to also move technology forward. More recently, we see floating wind coming up. Can you tell us a little bit more on that and how that helps speed up the transition?
Yeah, certainly. And just to start with that, we initiate and run more industry projects than any other organization in our industries. And those projects where we have this cross-industry collaboration, they are almost all geared up to producing recommended practices, qualifying new technologies, as you said, or establishing new industry standards. And all of these are very important to kind of get industry performance up there and also to get the cost down. And I think this standardization is extremely important. And so we have first-hand experience for decades, I would say, seeing value coming out of this cross-industry collaborations. And an important technology now for the energy transition will be offshore floating wind. And the only way to make that successful is through, I believe, cross-industry collaboration. Offshore floating wind has to lean heavily on the offshore experience gained over many years from the oil and gas sector, and to blend this experience with the experience of power producers, offshore construction contractors, vessel owners, OEMs, and of course construction yards, to mention a few, to get the cost down, because offshore floating wind is still a novel technology and still very expensive. So standardization and cross-industry collaboration to make sure we get maximum learning from related technology components, it's extremely important to get that moving.
Yeah, thank you. I think very promising offshore, floating offshore wind. Sheri, this also relates to what you said earlier in the conversation, that the industry also should work more together with suppliers and form partnerships. Can you say a little bit about your ideas on that part?
Yeah, absolutely. And I think there's two pieces. One is definitely the technology. So as Remy talked about investing in how do we bring different industries together that share technology, different expertise in technology. You know, some of the best innovation is not always going to happen in-house. And the more we can bring those minds together to solve the problems with the different expertise, the better. You know, some of the things you're seeing now are 3D printed blades, for example, being tested. 3D printed towers. If you think about the cost reduction, if we can actually print a tower on site at location versus what's actually the industry is demanding, which is larger and larger towers for the size of the wind turbines, specifically referring to on land. So really trying to partner, whether with its suppliers or other industries that may have unique technologies, you know, the aerospace industry with the blades on turbines. So, you know, there's a lot of cross collaboration that can happen. I think Remy's example is fantastic when it comes to offshore, because you have construction, offshore construction. You even have like trying to develop the vessels that have the large enough size to be able to carry components. So it really will take the best brains out there to solve the problem. I don't actually have a concern that we can solve the problem. I think just like the leaders on this panel, it's how quickly will we come together to do it. And that's maybe the other half where I think the cross collaboration can really help the transition. And that's across the industries from a different perspective. And that's from OEMs to developers to grid regulators and to country levels. And how do we start to think about operating grids in such a way that it's no longer about putting a turbine on the grid or putting a farm on the grid, but we're thinking about the system as a system. and how do we optimize a system instead of really being transactional. I use that word, transactional, just hooking up the next turbine, for example. And I think if we can think broader, we can solve and find more flexibility in those solutions to bring more renewables to the grid faster, because I do think one piece is technology and cost and driving that down. The other piece is going to be connecting it and having stable electricity when we need it.
Yeah, thank you. That was, I think, a lot of good insights. And that also goes a little bit already in digitalization and what that means. I think we can hardly say anything about this industry without talking about digitalization. Um, maybe Andrew, could you say something, because you're very passionate about mathematics and how that mathematic modeling, how could that help? Can you explain a bit how you see mathematics also related to engineers and how important engineers are, and how we can speed up the digital
Yes.
transformation?
It's a pity I can't move my camera, because on my study door over there I have a stencil of Euler's equation. So every morning when I come in, I can see the equation, which inspires me. Yeah, the only reason why we've got as far as we have with 220-meter diameter turbines and still growing is because we are able to predict now really very accurately how they will behave. So the industry, of course, all sorts of other skills of design and manufacturing and so on come along too. But understanding the basic physics and the response of the turbines to all various inputs has been absolutely crucial. So yeah, I've spent my life on mathematical modeling of turbines. So I am particularly enthusiastic about it. But it'll go on. And Rem has mentioned the offshore floating. So we're starting a whole new type of turbine. I think we've had onshore wind, which has now pretty much become a commodity. We have offshore fixed base wind, which is developing. It's going to change a lot, but you can sort of see the way it's going. And then we've opened a whole new era with floating offshore. And there, I think the collaboration of the engineers from different disciplines is going to be crucial. But again, until we can understand how they behave, we can't design them economically. I think we talked a little bit about what's needed in the way of policies. But a theme of my life has been to see just how well engineering responds to a challenge. So if you have a policy challenge, an engineer will respond to it. And I don't think any of these problems we're talking about are really going to be technical. They're going to be getting the technicians or the engineers to apply themselves to the right problem. And probably that problem, again, through mathematics to start with, will be integration. So we can generate, can we transmit and distribute in a sensible way? I think that's the big challenge for our industry now.
Yeah, I was thinking, Remy, coming back to you, also related to what Andrew just said. Thank you, Andrew, by the way. Is with digitalization, it sounds easy, but you will see that it can also be a barrier. Everybody is sitting on their own assets and their own intellectual property. What kind of mechanisms could we be put in place to ensure that we have a kind of fluent digital space?
Yeah, I think it's not an easy answer to that question, but I think digitalization is a key enabler for the transition to happen faster. In general, we are seeing that it's a technology-driven transition that is rapidly moving away from large, fixed, attractive and extractive assets to move much more distributed models for generation and distribution and use. So I think digitalization will be important enabler for that to happen. And to just add on what Andrew said is that math is extremely important and engineering is important. And what we have at hand now, it's much larger range of sensoring that we can deploy, and we can have a much better connectivity, and we have ability to use massive amount of data into what we call machine learning. So, and through that we can develop better designs faster now than before. We can take out operational inefficiencies, you can say, through more real-time monitoring of the assets and to run machine learning algorithms almost real time, which again will increase the commercial attractiveness of the needed technologies that we need to move faster on, which again will fuel the transition. So I think what we have now that we didn't have 20, 30 years ago is this connectivity between the assets and the ability to learn much faster and to bring that back to the improved designs, and also to make most of the design that is already in the operations. And that, of course, will bring the whole commercial attractiveness up and cost down. So I think this is really important that we take advantage of it. And I don't think we will get a transition fast enough if we are not using digital technologies to fuel it.
Thank you, Remy. Maybe a little bit related still to this topic, Sheri, you mentioned the interesting concept of living wind farms, which I think relates also to what Remy just said, where everything will be connected, and also what Andrew mentioned. Can you say a little bit more about turbines and systems and how you see that part?
Yes, absolutely. I'm a big believer in this. And when I refer to living wind turbines, we can use an analogy with a vehicle. For those of you who are familiar with Teslas, you know that they can download software over the air and you can have a new horn sound for Christmas, like they did this last year, which is a very interesting dynamic. And I call that a living car versus a dead car. A car that's produced on an assembly line comes off the line. And really, to get a new software package, you have to go to a dealership or some other location to get that downloaded physically. How do we move to a pace where we have living wind farms, where we continually can use our optimization efforts and learning? Because I agree everything with what Remy said, both from the machine learning and also then what that can do from a productivity perspective, what it can do from just gaining knowledge on the operations of the farm, where it can continually improve its optimization of how it runs itself. So instead of us managing maybe from a remote office, each small tweak when that turbine has an anomaly, the turbine can actually manage itself now 80% of the time, and we only have to step in 20% of the time. And if we can have a situation where you can reflash, that's what we would call that, reflash the turbines as we learn. So the sites that are out there that are 5 years old can still be living and growing and learning like the new sites. That's where we will continue to advance ourselves much quicker. I think there's also a really interesting point around the fact that the wind industry wants to move, the technology wants to move faster than what we can actually learn how it experiences the environment. So when you think about onshore wind, where I am at, in China, for example, a wind turbine model may have a 6-month to 18-month life cycle. It's barely enough time to get enough turbines built, learned, understand the loading on that configuration to implement it into our next round of designs, especially if you have to have one prototype, for example. So we can use this digital data collection and these sensors to understand much faster how the turbines are reacting and putting that into future designs. So future designs can be developed more efficiently, and they can be launched in a faster mode, which we're only limited really by ourselves, how we have the capability and knowledge to make sure we're developing quality turbines that can live in the environments we put them in.
Thank you. I think a lot of interesting developments with regards to how by collaboration also we can move forward. Albia, is in what way is I think Brazil is a fast developing country for wind. How do you see the role of digitalization in your country, or maybe globally from your GWEC role?
Yeah, when we talk about new technology, such as we are discussing hybrid wind solar power plant. We start to discuss recently green hydrogen, batteries, and offshore wind. Especially in Brazil, we started to run with projects for offshore wind. And we noticed that our subject here is about our energy metrics, highlighting electricity metrics. In the past, we had basically thermal plants with hydro plants. In the last 10 years, because wind offshore, we changed a lot, and we have some challenge to face. And it's very important to increase digitalization process innovation process in order to look for efficient use of energy resources and sustainable development and climate change. The National Energy Plan for 2015 from the government from Brazil, they put these bases, innovation, digitalization. And we need to provide electricity for a big country, and this process needs to work very well. We say this is when we're talking about the supply energy and the supply technology in order to guarantee supply for Brazilian society. And it is very important to put together this digitalization process and new technology, because we need to operate our system. The real operation system is very complex, and you need to use this new technology and digitalization process. We need math all the time, because we need to calculate what we will have sources for the next day, for the next hour. Our market has been changing, allowing regulated process too, and it's very crucial for us to invest in digitalization process and the new tech for in order to have a prediction about what will happen with wind, what will have solar, and we will have sources working in time that we need.
Thank you. Thank you, Albia. I want to switch to a different kind of topic, because I think we all believe we have the technologies, we have the digital technologies, we understand the mathematical modeling and how that is going to help us. But looking at the current energy industry, not sure if it's really diverse already. That might be an understatement. But how can diversity and inclusion help a faster transition? It's a big question, of course. I know, Sheri, you mentioned an interesting, let's say, topic called the happier transition, by doing it in a different way and including different talents. Can you elaborate a bit on that and what you meant by that?
Yes, thank you. I think we just stumbled across that phrase as we were chatting, Caroline, when we chatted. But, I'd kick off by saying something that reflects back on a question you asked us, and it's how can we cross-collaborate across industries, across leaders, to make the transition go faster? And I would turn that statement back right around on us. It's the same as with diversity of thought, right? We're looking for the right skills, the right mix of skills, more ingenuity, creativity to solve our problem faster. And I think there's studies done that show diversity of thought can increase by at least 20% from an innovation perspective when you have a diverse team. Where I think the happier transition comes in is, I believe we've probably all worked on a team, can think of a team where we felt that we could bring our whole self to that team, where we were accepted for the thoughts we had, where we felt comfortable to make mistakes, and we could really be creative. I think we can probably also think about a team where we didn't feel that way, and how we actually limited our own inputs, our own solutions, and quite frankly, our own commitment. And so, I really do believe that when people feel fully included, when they feel fully capable of bringing their best self, the businesses will absolutely benefit from that. You will see more efficiency, you'll see faster solutions, you will see more commitment, you will get more out of your teams, but you actually will have higher employee satisfaction. You will have more passion and engagement. And I think that's where the happier transition comes from. So sometimes I wonder why we make having diverse teams such a challenge. Why do we talk about it, that it's so hard? Because in the end, it'll actually solve the problems we're trying to solve faster if we can bring in that diversity of thought.
Thank you. Maybe a little bit more, because I know GE has made big steps with regards to diversity, getting also more female engineers in the company. Can you tell us a little bit, so that other companies can learn from it, which step you took as a company to approach that issue?
Yes, thank you. So GE is actually taking many actions with respect to diversity. And first and foremost, it's starting with publicizing the data. So we are not in a position that I'd say we want to be in. I think we can all agree that the population is 50-50, male, female. So from just a gender diversity perspective, until we reach that, nobody can say that you've solved the challenge. So first, admit you have a problem and then go work on it. And even like Andrew talked about, when Europe set targets for energy transition for renewables, that's when they hit them. So we haven't set official targets, but we actually are putting strong goals and internal goals on ourselves to increase our gender diversity first, but also looking at how can we more broadly look at diversity. A few of the specific actions I can reference with respect to engineering is we have a hiring program where we attract what we call Edison engineers into a really great rotational engineering program. We set a target of 50% women into that program, and we've achieved it. So that is really a fabulous step forward, especially in the technical fields. In my own space in Asia, we set a goal as a team to have at least 30% of all of our new hires be female. We just set this goal in December. And what I was just talking with my HR partner today, and I said, how are we doing? Well, already for the hires that we're making, we're at 25%. We started at less than 15, and we're talking about project execution and manufacturing for the majority of our hires. So I bring that up because I think if you set goals, if you're really committed to them, the diversity is out there, but you have to commit and you have to say it out loud and you have to really work towards it and hold yourself accountable. And that's what GE is working to do.
Thanks, Sheri. That was a really good insight in how GE set itself targets, and I hope other companies can learn from that, helping the world go more into a diversity mode, because it's really needed. LBI, you told me 20 years ago you were the only women in wind. Can you? How is it now? I know, of course, Brazil is a very diverse country in all aspects. Could you give some reflections on diversity from your side?
Yeah, I would say that nowadays our situation is better than 20 years ago when I started my career. Um, as I used to say, I was the first woman in a lot of chairs in a lot of places. 9 years ago, when I started at the Abeólica, I was the first CEO in association. I was the first one, and I am the unique CEO yet. But I think Brazil has been changing mainly because when you look for wind, for example, GWEC, the Global Wind Energy Council, has a very important program with a Women in Wind Global Leadership Program. I am an ambassador there. We have programs that we have a network contact, we have a mentors program, and it is very important. In Brazil, this discussion is starting to improve now, mainly in the side of the market. The companies that they are investing in energy, electricity, they are looking for include, for diversity, and looking for change. We are changing our metrics, but I believe that we are changing the behavior in company. And I believe the way now is better. Maybe we need to improve speed, because if you look in companies, we understand that we need more diversity. But I believe that you are in very good way, and I personally has been working hard in order to change this culture here in Brazil, and I think we are good, in very, very good shape.
Yeah, so we're moving forward, and I think that is really good news. Andrew, I also know that you are a true believer in that we need the best of everybody, and that there is a huge lack of female engineers. So you've been a mentor of female engineers for many years, but you're also a sponsor of the Black and Green Ambassador Project in Bristol. Although this might be a local project, it sounds very interesting, the Black and Green. Could you tell us a little bit about what that is and how that is going to contribute to the transition, in fact.
Yes, certainly. But can I just make a brief comment on what's just been said? I think what Sheri's doing sounds fantastic, but there's a danger if she recruits all these women that they all go to GE, because the problem is a much more basic one, that we don't have enough young girls getting into engineering. So something the wind business could do would be to really push at a much earlier stage, I think. The NVGL has done very well to get 50-50 on this panel, but I remember being on a panel at EWEA about 10 years ago, there were 8 of us, all white men in dark suits with ties on, all with black shoes, all had their legs crossed, and I've got a picture of this. And the only diverse thing was I had my legs crossed the other way around. That was it. And so we've moved a long way. But yes, I was the chair of something called the European Green Capital, which is run by when we used to be European, it was lovely. And Bristol was European Green Capital. And what we noticed there was we have quite a large BME population in Bristol, but engaging that community into green things, the environmental things, was difficult. And we teamed up with a local radio station, a black radio station, which was successful. And out of that came this thing called, can't remember whether it's green and black or black and green, because one is chocolate and the other is our activity, and we have to be careful to get it the right way around, otherwise we get into legal difficulties. But the purpose of this is that we've appointed 3 youngish people, sort of early in their 20s, to go out into the BME community and talk about environmental issues, to engage that part of our community very, very directly. And there are, of course, other parts of our community which need a similar approach. But it's already been very interesting. And of course, getting everybody involved, and this, as we mentioned earlier on, is crucial. So we can't just have the white middle-class people doing this. This is no longer a white middle-class hobby. It's something which actually is vital for all humanity, and therefore every part of our community, every part of our society. And so that's what we've tried to do. We'll see. Maybe we can report back in a year's time how we get on, but it's looking promising right now.
Yeah, thank you very much, Andrew. This brings me to the last topic of today, which is a just transition. And so we can do the transition, and then rich people can put nice solar panels on their roof, but we don't want to leave other people behind. This is, within countries, but also between countries. Is how do we ensure globally between the developing and developed countries that we have a good mix? Also, those countries who still have energy hungry, still want to move up and get everybody, ensure that everybody gets access to energy. Albia, do you have from Brazil perspective, what could be done not only in Brazil but at a global level to move faster, but still let it be a just transition?
Yeah, it's important to put Brazil in context when we say about energy transition, and in order to put this fast. Brazil challenge is a little bit different from other countries, because when the muscle part of the global is looking to improve and to look for more sources, because it is scarce. In Brazil, renewable is very abundant and is very competitive. And for this reason, I believe that is opportunity that nowadays you don't have money to prepare big package for green recovery, but we have opportunity to have competitive renewable sources. In this way, I believe that the Brazil challenge is to manage the abundance of resources for energy production. And they always taking into account to preservation the environment and the social environment. But I can see a very important opportunity when we say for economic, for Brazilian society, that transition for us needed to be to have other way to understand, because I believe that the energy transition is a big opportunity to transform our society, to transform our society to include more the most part of society that need to better conditions. And with renewable, mainly in the northeast, this is the region Brazil, we have a good experience with wind farms, because we can contribute give the real contribution for social development in municipalities, and improve renewable energy, but we can improve new jobs, we can improve new rent for this population.
Thank you very much. I think this is maybe a nice point where we can end the discussion how a faster energy transition can transform society. That would be fantastic. So thank you to this fantastic panelists today, and with a lot of interesting insights. Let me make a short summary how we moved from how leaders can step up cross collaboration in the industry, within the industry, of course, together, but also with suppliers and forming partnerships and ensure we have standards together to move forward. The role of digitalization, how that plays, it's almost the fuel of the transition. Also linking the various partners together, again, also through standardization and other platforms, even thinking about living wind farms and how these would work. But also look at other industries to learn from, let's say, almost, it might not be nice to say, but from the old industries, use their technologies and their insights into our industry, which is newer. But of course, and also look at how can we within the energy industry connect the wind farms with solar, with hydrogen, with the grids, and make it a more systemic approach. So thank you, panelists, for being here. We are moving now into the Q&A session. So to the audience and to the listeners of this session, if you have any questions, please stay on so I can go into the questions and answers session now. Thank you. We now have 15 minutes Q&A, and I have a question for, well, there are many questions already, so I just picked some because we only have 15 minutes, and we'll come back to the other questions directly in your email box. There is an important question regarding digitalization. Remy, maybe you could look at that because it's one of your big topics, of course, from Torsten Peters. Should the access to data be more open so that more people can use it? What's your view on that?
The short answer is yes. Of course, there is IP issues here in terms of data, but I think if you look at other industries that has moved fast, they have found this fine balance between keeping what is really a secret and what can be shared to drive industry forward. And typically both reliability data and safety related data has been shared widely in other industries, and I think this could also be stepped up in moving renewables forward.
Mm-hmm. Thank you. Maybe very quickly related on digitalization and security. I also saw a question on cybersecurity and that there might be more cyber issues and cyber crime when there are more data out in the open. What's your view on cyber crime with data increasing?
No, well, I think when you become more digital as a company, you are exposing yourself to these threats. So that's comes with the with the game, you can say. But there are, of course, methods to use there also to minimize the risk of cyber crimes. And I think data can be shared, as you asked about earlier. With the purpose to move the industry forward. And then in that perspective, I don't think cybercrime is the main issue. But of course, when you are moving into more cyber physical systems, cybersecurity is an issue you need to manage. It's the other side of the medal.
Yeah, thank you, Remy. There are more questions. One is an interesting one. Maybe go to one of the pioneers in the wind industry, Andrew Garrad. There is an interesting question from Tucson, asking from an environmental perspective, what is the biggest advantage of offshore wind compared to onshore wind?
Well, I think that they both have their merits. I mean, the main purpose, I think, of going offshore is space. So if you're in a big, wide open country like the United States or China, you have to ask, why bother? If you can go to Texas, why go into the sea? If you can go to Inner Mongolia, why go into the sea? So you can have huge developments, power station size developments offshore in Northern Europe. I mean, Northern Europe is leading the way right now. So the environmental benefit, I guess, I would say it isn't specifically an environmental benefit. There are different environmental impacts. Probably it's easy to think that they're less offshore, but of course they're all there. Onshore, there's flora and fauna and people are usually the main barrier. So I believe that wind turbines look like they do now because they've had to be good neighbors. And what we're actually seeing happening is the turbines changing as they go offshore. So the big offshore turbines you could not possibly have onshore because of their sheer size. So it's a bit more subtle than just environment. I think it's all sorts of different things, and they'll both continue. They'll both continue in parallel, one with another.
Could I just add to what Andrew just said about offshore and onshore? Just a short comment. I think also if you look at where people are living in this world, it's close to the coast. And a lot of the big cities are close to the coast. So it's also a matter of transporting and getting the energy to where it's going to be consumed. And here offshore, I believe, has a slightly better, I'd say, opportunity than onshore wind, which could be in remote areas.
Yeah, actually, it's interesting to look at we did some work offshore in China and onshore in China and in Mongolia, and the choice there was the 3,500 kilometers of high voltage connection from the high winds in Mongolia, or very close by low winds, interestingly in China, lower wind speeds in the sea, but much closer to load. Normally we think of the wind speeds offshore as being higher, but actually in China it's exactly the other way around. So it's a balance of all those different things.
Yes, thank you very much. I don't see Sheri anymore, so I think we have to check with Andrew, as you are also, of course, very much interested and knowledgeable about wind. How can OEMs affect the energy transition more? So those who manufacture wind turbines, how can they impact the energy transition more? And a related question to that is also the thing that came up in the panel on 3D printing, and that of course is mainly applicable to plastics. Is that sustainable? So looking at also the materials that we use in wind turbines, what's your view on that and related to a circular economy?
Yeah, well, I think the biggest shadow I think that we have over our industry is what we do with the large number of composite blades that will reach the end of their life in the next, starting now. There's work on that going on, and there was an attempt some years ago to use thermoplastics, which could then essentially be recycled. That wasn't terribly successful. At the moment, the best thing we can do is to chop them up and use them in roads or in insulation, which is not a good solution. So I think that is the biggest shadow we have. I'm not qualified to talk about printed towers. I mean, given that I'm an engineer, and in the earlier talk I was saying the engineers will always rise to the challenge. Perhaps they will. But on that particular subject, though, I'd like to think a little bit about materials generally. And a really remarkable thing I saw last year was the launching of a wooden tower. I think there's a Swedish. I think it's called Modvion, a Swedish company building a 100-meter wind turbine tower in wood. And I think that's really exciting. We used to be involved in wooden blades, not solid wooden blades, but wooden laminate blades, and they're continuing. But a 100-meter wooden tower is very exciting. What could OEMs do? Well, absolutely everything. I mean, I think the really interesting thing you've seen recently in the OEMs is that the ones in the front now, okay, there are a couple left which are pure play wind, but a lot of the big names from conventional power have moved. I mean, actually given up nuclear, for example, and gone into renewables and wind. So the OEM play absolutely crucial role, and I think they are embracing wind, perhaps for nothing to do with the environment. I mean, maybe simply because it's now a very good business, and I've certainly been a big proponent of it being a good thing to be able to earn money out of wind. It isn't a bad thing to be frowned upon. It's absolutely vital if we're going to make a big difference. So OEMs are right in the center of the whole thing, and I think are performing immensely well. If you look at how the turbines have changed over the last decade, it's just gobsmacking. I mean, when I joined the business, I could carry a big wind turbine, a full-scale wind turbine blade on my back, and now they're 120 meters long. Wow. And I don't think we make enough of that. That success, that incredible achievement, is something we should shout about a bit more.
Yeah, so we should celebrate more where we are today. Thank you for that insight. I have a very different question that also came up on the impact of COVID, of course, and that's a question for you, Remy. I think because it was directly directed to DNVGL. So we are all working from home still. We don't know how long, and that has the only positive maybe is that it had a really impact on emissions, on CO2 reduction in the past year. So the question is, what will happen after COVID? In DNVGL, I know all about that. We don't fly anymore. We are an international company. What will happen after COVID? How do you see that for our company?
I think we will see a hybrid. There will be some flying again. I believe it's about people want to meet each other, and also it's important for having a good collaboration over time. But I think we have learned a lot that these digital technologies and the platforms we now see will be used a lot more. So we'll not go back to where we were, but there will be some travel, and particularly when you have creative processes and innovation processes, you see that the process suffer a bit when you have to do it digitally. So we think that creative part will be done more in physical presence, while more transactional sharing information will be done digitally. And a lot of the work will be delivered also digitally. So that will definitely continue and will be done even more so in the future than during the COVID, because we have learned a lot in how we can deliver services in different ways. So a hybrid model, but not coming back to where we were. So we are now designing what we call the new workplace, and yes, that will look differently than today.
Yes, thank you. I'm looking forward to that. Unfortunately, we lost two of our speakers today. I think Sheri in the turmoil of the system issues, and Elbia could not be here today to answer questions because she had personal health issues. But I still want to come back on the, let's say, diversity topic, which was also part of the discussion here. There is also a question: will regulation help from Mr. or Mrs. Garrad? Will regulation help with regards to diversity?
Well, I was pushing regulation with respect to energy diversity, so maybe it also applies to human diversity. I think it's rather more awkward. I must say, I was thinking encouragement rather than regulation, but I made the point in the previous session that I think it begins much earlier than we think now. I was on the council of the university, and we had a meeting where the head of the veterinary school came in and said, I don't know what to do, because if we take all the best qualified students, all the veterinary students will be women. So what do we do? And that must have happened because of something much early on in life. And what we continuously fail to do in engineering is get hold of the female talented people right at the beginning when they're at primary school. I've done a little bit of work on that recently. So I don't think we can regulate for women to come into engineering, but I think we really, really must encourage them, but at a much, much earlier stage.
Yes. Thank you. Remy, you want to comment on that as well?
Yeah, no, I agree with Andrew here that it should be because we can do a lot more by having more diversity, and we have to start early. We have to show role models that have succeeded and done great work and made a career in the industry, and start early on. Passion for mathematics that Andrew was talking about in the panel debate earlier, and physics. So I mean, it starts very early, and again, to combine that with showing role models, that I think that will move us in the right direction.
There are some great role models in this industry. I think I mentioned earlier on, I quite often talk to groups of girls at school, and one person I often bring up is Christine Abo, who is the R&D manager of Ørsted, the world's biggest offshore developer. The technology lead there is a woman, and that's she's a great example. I mean, there are lots of others as well. So we shouldn't get too depressed. I think we've got some quite good examples, but we've got a long way to go. And I used to look, when I was running the Garrad Hassan, I used to look quite often at where we had women and where we didn't. And it was actually counterintuitive, because the place we had the most women engineers was in the Romance languages. So particularly in Spain, which was run by a woman, of course, which probably helped. But 60 to 70% of the engineers in Spain in our office were women. And the lowest was in Scandinavia, which is just exactly the reverse of what I would have thought. And I think it's partly to do with the way science is taught. And it's much more analytical in the Romance languages than it is in Northern Europe. Oh, Sheri's back.
Hi, Sheri.
I'm having a ton of issues. Yes, I'm on my iPad, so hopefully you can hear me okay.
Yes, we can hear. It's fine, fine, Sheri, because I just thought about wrapping up, but now you're back, so I think it would also be good to to also have. We had
don't ask me the hard ones.
No, there is one. I think it's related to the living wind farms concept that you launched last week. Can we give each wind turbine is a sentient, let's say, conscient identity, and would that be useful?
In some ways, yes. I mean, you want to have identification actually of the wind turbines, and you actually want identification down to a part number, because you want to have tracking and understanding from a quality perspective, a safety perspective, and especially when you're root causing problems, that actually does become very handy. I think it's probably a longer dialogue, and it would be a back and forth, like, well, what do you mean, and what is your intent by it? But I can just maybe leave with one note. I think this is something that we can learn from other industries on how they actually name, sequence, record, and maintain that knowledge on their products. Because when you have a product that's to live 30 years, think about the number of people that will transition through the company, yet that turbine is still standing, and you want to know like what that turbine represents. So the short answer is yes, I think there's a lot of value in doing that.
Yes, thank you. I'm looking at, we covered some of the questions. There is one more related not to diversity, but also to how can we include more the poorer communities, and should we do more around scholarships? And it also relates, of course, to what Andrew already mentioned, that we can't start early enough. Sheri, is there anything from GE that you can say about that, what you're doing to get different people, but also people from, let's say, unprivileged communities to get them into GE? Andrew, do you have a view on that? I hope Sheri will be back in a minute.
I have a very amateur view on it. I think one thing that's happened during the COVID is the return of the expert and the increase in the visibility of science, and thereby possibly engineering. And so I think the attractiveness of this sort of activity has increased a lot. And so I think people will be drawn more into engineering and scientific activities than they previously were. And part of that is apprenticeships, rather than pure academic study. And I think that's a very important thing as we turn to a new era where making things is actually important again. And last quarter, I was very pleased to see that Elon Musk, who, I mean, he's got plenty of idiosyncrasies, but he's making stuff. He's making stuff, and he became the richest man in the world rather than someone who was just fiddling around with computers. And I thought that was very encouraging. So he's making kit, and so making kit suddenly became glamorous in another way. So I think attracting people into making green technology through all sorts of devices, but including apprenticeships, will be a very valuable thing to do.
Thank you very much. Maybe you want to have a last view on that, Remy, and then we wrap up the Q&A session.
Yeah, I would like to say that I think the energy transition is making the playing field more even, as the transition will take us to use more indigenous resources, where distance between production and consumption will be shorter. And also the faster we can transition, the more we will limit global warming, which is today hitting the world population in an uneven and unjust way. So I think the energy transition will make the world more just. So the faster we can do it, the better it is.
That is a nice way of ending this Q&A session, making a more just world by including everyone. Thank you very much, Remy, Andrew, and of course, Albia and Sheri. I'm not sure if they can hear me, but Lisa would like to thank you, and also thank the audience who has stayed until the end. And we'll enter into the expert session now. Thank you very much, and talk to you soon.
Yeah, so maybe I noted a couple of them down. So there were some easy to answer. So there was one question about solar versus wind and how we see this develop.
Yes, that was the very first question, I think.
And if we look into our own formulation, then our energy transition outlook, we assume that 62% of the variable renewables, or 62% will be variable renewables in the electricity production. And it's about a split of half solar PV and wind being onshore wind, offshore wind, and floating offshore wind. So that's an easy answer to that question.
Yes.
Then there was a question about cybersecurity, which is a really relevant issue to discuss. We are, of course, excited about better connectivity, about more data being exchanged, but that also makes systems more vulnerable. And this is something which the energy industry as such has recognized. So there are cybersecurity bills in many countries around in the world who especially also target the energy sector. But we have to say that in wind, it's still a little bit ignored because we didn't, fortunately, have any huge events yet. But if wind farms contribute 31% of our electricity production, something could happen large scale. So this is something becoming very important in the next couple of years.
Yes, thank you. I did not properly introduce you because it's a bit a chaotic setting with the trouble in the beginning. So we have maybe very quickly, Matthias, you can introduce yourself, and then also Onur.
Yeah, very good. I'm in the company since 17 years. Started as a civil engineer, built up a few renewable advisory businesses in Asia Pacific later, went then into our digital business, and I'm now back looking after renewables Germany, here from the north of Germany.
Yes, thank you. And Onur, maybe you can introduce yourself?
Of course. My name is Onur Özgün. So I'm a principal and researcher in the NVGL's Group Research and Development Unit, and I'm the modeling responsible for the NVGL's annual energy transition outlook. I am with the company for the past 5 years, industrial engineering by training, and my expertise is in energy systems modeling. And also I was involved a lot of commercial projects in this company on creating a few net zero carbon emission scenarios as well.
Okay, thank you, Noor. I suggest that because we are a bit delayed now, that we continue for 8 minutes and then we end this session, so that it's clear for everyone how long. Because I said we still have an audience of 360 people, which is quite significant. So,
But why you pick one?
you pick one. Yeah.
Yeah, while you pick one, I can maybe just bridge it with another thing. I think one thing we haven't discussed in this panel, which is also important to transition faster, is the markets and the business cases. And I guess there is a big importance also for us, like as consumers, to get into the transition, being incentivized, so to say, by going for renewables. And I think that's also a big thing which has to happen now in the countries that these models come out. We see, I think you mentioned that in the session, some rich people put solar panels on their roof. It shouldn't be like this. It should be like we actually produce now, because we are at the levelized cost of energy, which has grid parity in many parts of the world, that it becomes the more affordable solution to do that. And I think in some regions it is the case already. We just then need the business models to support this.
Yeah, thank you. I think that's a good insight. Onur, you mentioned, and that might be very interesting for the audience, the role of modeling, and not only from a technical perspective, but also looking at policies and behaviors, all the various aspects together. Can you tell us a little bit about that, how you apply that in your research work?
Of course, what Andrew talked about is, of course, very critical. So mathematical models is core to improve the industry. So we have also our colleagues in DNVGL using models and machine learning for improving wind farm control, predictive maintenance for PV panels, role of flexibility. But modeling also goes beyond engineering problems, also looking at the whole of the energy system as well, looking at the feedbacks between the various parts of energy system, because that's quite critical. As humans, we have a kind of a linear thinking, but in order to understand how the whole system will evolve over time, you need to look into the behaviors of the people, how actual decision makers make decisions in life, what are the delays in getting information and being implemented, and how these really pan out in real life. So we are using system dynamics modeling, which is a feedback-driven modeling system that looks into socioeconomic systems, and also very close collaboration with our business colleagues who provide us with the latest data in the industry. So we are combining the strengths of having a holistic approach to modeling, as well as using the latest available information in the industry, which is a problem for some of the academic work, because they don't have this connection to what's happening in real life. It's usually there's delays in publishing and reviewing, that sort of things. So in Energy Transition Outlook, we try to also close this delay, and also looking at how everything interacts with each other.
Okay, yeah, thank you. That is so important, also that people start to work on that very early, and then so we can really apply that in real life. A question on emerging markets. We heard Albia from Brazil talking about how important it is for Brazil to get investors in from outside the country, because there are no subsidies, and the country does not have enough money to develop that market. You lived for a long time in Asia, and you were in various emerging markets, as we say sometimes. Can you elaborate a bit on that? And
yeah, that's very interesting. I think especially my experience comes from India and China, where I saw the markets growing. And what was quite interesting, and what was a big learning experience also for us, which I think is helping us now in the transition, is that if other countries start with an industry which sounds common to you, they still may have very different problems. And Andrew earlier talked a bit about offshore wind, and that was a very interesting thing, because we had all our knowledge really from the North Sea, doing the design based on Gulf of Mexico standards, which we learned from the oil and gas industry. There was nothing better. And then we tried to transfer that knowledge, for example, into China, who have completely different soil conditions, very soft soils, but on the other hand, very shallow waves. So it links to that story Andrew told us earlier, that they had this contradiction about the high winds onshore, and the low winds offshore, which would be something you wouldn't think from a Western world. And that, I think, is so important if we go into these markets as investors, as consultants, but also the market itself, that there's always this local component which really needs to be understood, and it's not the same story that fits everywhere.
Thank you. Very clear. I don't know who the best of you, that maybe the last question for today, but of course there are important questions related also to environment, but also to batteries, and what will the role for batteries be, especially when looking at the off-grid sites?
Yeah, perhaps I can start. Of course, you know, in a system where there are a lot of variable renewables with solar and wind, flexibility would be key to continuing this energy transition. So batteries will play a significant role, of course, to make sure the system is balanced, and particularly on not to maybe minute to minute, but also long-term flexibility, of course, and the business opportunity will manifest itself more as you have more variability in the system due to variable renewables. But of course, initially support would be needed. But of course, batteries will be the only solution to provide flexibility. This has to be combined with other options, demand response, better demand response. Power to hydrogen would be also key in the energy system of the future. So definitely there's a significant role for batteries and also other flexibility options.
Yes, thank you. Thank you very much to also enter into the flexibility message. I'm going to end this session because that's how the program is set up. Thank you very much, Onur. Thank you very much, Matthias. And of course, thank you for your patience and your attendance, for all the attendees and the participants today. Thank you.
Okay, thank you.
Bye.
Thank you.